All right, thank you, Ben. And first of all, thank you everyone for sticking around. I know it's been a long day, so I'm going to keep my introductions very short. My name is Yan Cui, and I've been a long-time user for AWS. And right now, I'm working for a company called SpaceX Games, where I'm making mobile games for a living. Unfortunately, I can't tell you anything I'm working on because it's all heavily NDA'd. But before I joined SpaceX Games, I actually worked in a social networking startup called Yubble, where we were trying to build something that's similar, that you can think of as a mix of Instagram, Twitter, and Facebook. And it was there that I learned a lot about AWS Lambda, and specifically some of the challenges that you come up against when you try to run a serverless architecture in production. So when I started at Yubble in the 2016 April, we had a pretty simple architecture, at least simple on paper. Everything was monolithic, everything was running on EC2 instances. And being an early-stage social network, we didn't have many users. In fact, the baseline usage was pretty low, but we did have a handful of power users who had, like Emily here, tens of thousands of followers. And these guys, they do a very good job in terms of running effective social media campaigns on our platform. Emily, for example, would often post on our platform and say, hey guys, come and vote on my post, and then 10 o'clock, I'm going to announce a winner for this beautiful designer handbag. And sure enough, come exactly 10 o'clock, tens of thousands of people just flood into the platform, and we get these massive spikes of traffic, often 70 to 100 times of your baseline. And as an engineer, this is the last thing you want to see. I mean, how do you provision your system to cater for that kind of spike and then nothing afterwards? So it means we have to run our cluster at a much lower utilization than we would like, and because EC2 scaling is very slow, we have to also scale up a lot earlier. And put the two together, it means that we are spending a lot of money for resources that we're not using. By my estimation, we're probably using somewhere around 2 to 3% of what we spend on EC2, which is, if you think about it, is ridiculous, right? And also, deployment at the time was taking somewhere up to 30 minutes and required downtime. So the whole system goes up, goes down, and goes back up with 30 minutes of downtime every single time, which is no wonder why deployment doesn't happen very frequently in that case. And nowadays, that's just not good enough. And one of my favorite speakers, Dan North, once actually said that the lead time to someone being say thank you is the only reputational metric that matters. But of course, for someone to be able to say thank you for your work, you have to first deliver value to that person. And to do that, as engineers, we have to ship our code. Until our code is shipped and running in production, to our users, we just haven't done anything at all. So joining Yubble, I know what I inherited was not good, but before we can manage to build something better, we have to first know what a good architecture would look like for us as a company. So I sat down with the team and we came up with a list of criteria of what we want from our architecture. From a deployment point of view, we want deployment to be small, to be fast, no downtime, and we don't want to be in a situation where we had to do a lockstep deployment with the client teams because of the sheer amount of coordination and stress involved. As for features, we want them to be loosely coupled through messaging, and we want them to be independently deployable as well. And on the operational side of things, we want to make sure that we cut out all the fat that we had in our AWS build, and we want to minimize the amount of effort that we spend just babysitting the infrastructure. As far as I'm concerned, the architecture should work for us, not the other way around. I'm not the babysitter for my architecture. That's not the job that I signed up to do. At the same time, we had lots of technical mess to deal with, and that is a very conscious choice of wording. You see, when people talk about technical debt, the implication there is that at some point, some design decision was made to take out some trade-off with a plan to pay it back later. That's how that works. And what we inherited is obviously not that. But whilst we have all this technical mess to deal with, we don't want to take 6 months out just rewriting everything. We want to keep delivering value to our users. In fact, we want to deliver value to our users faster than we've ever done before. And if you just fast forward a few months, we ended up at an architecture that is both event-driven as well as service-oriented, with Lambda being the centerpiece that glues everything together. So at that point, we had something around 170 Lambda functions running in production, and we were paying for Lambda and API gateway about 5% what we were paying for EC2. So there's been a significant cost saving there. But perhaps more important to me is that the velocity that we were able to gain was massive, going from doing maybe 4 to 6 deployments to production every month in April. By October, we are easily deploying to production maybe 80 to 100 times per month with the same size team. But we know Lambda is a good fit for the direction that we want to go. But before we can even get to having that first function running in production, we have to make sure that we are able to answer certain questions to make sure that we can actually responsibly operate this architecture in production rather than just throwing whatever's in production and hope for the best. That means we need to answer questions around how do I do continuous delivery, how do I test these cloud hosted functions, what about logging, alerting, and monitoring, and so on. As much as I love Lambda as a technology, ultimately it's still just a tool. And even as we change the tools that we build software with, and the patterns and practices that have often evolved with previous generation of tools, they have to change and they have to adapt. But the underlying principles behind those patterns and practices, they still very much apply to us, and we shouldn't forget those. And we're talking about principles such as single responsibility, least privilege, loose coupling, high cohesion, and so on. And as our architecture expanded to include more and more services with many interdependencies, we also had to answer questions around distributed tracing, how to manage configurations and security, and so on. But even as we try to answer and work out solutions to those questions, we still manage to deliver a huge amount of value to our customers, whilst we also address the technical mess that we inherited. If you take the search feature, for example, when I joined the company, it was basically one big regex query against MongoDB. And as you can imagine, this just performed terribly, even when we only had something like 100,000 users. And it was really difficult to implement any sort of smart ranking on the search results. So as the first step of our migration effort, we made sure that the legacy system is publishing all state changes to Kinesis as events, so that we're able to build on top of those events. In this case, by having a Lambda function, look out for events that tells us when a new user has been created or when a user's profile is updated, so that we can update a corresponding user index in Cloud Search. And we can expose that search data with an API using API Gateway and Lambda. And whilst the client teams are still trying to catch up with all these new APIs we're building, we didn't want to slow down by waiting for the client teams to catch up. So what we also do as part of the migration process is to proxy the legacy endpoints to hit these new APIs that we are creating as well, so that, again, we can deliver values to our users earlier. We also didn't have much of an analytics platform to talk about, so we went about building one from scratch, and this was a multi-iteration process. The first iteration was as simple as having a Lambda function consume all these events that are being streamed into Kinesis and just live stream them to Google BigQuery, which is a BI platform that I've used for many years, and it works superb. And the first iteration took just one developer 2 days from that initial discussion to having something running in production. And at the time, our BI guy who's just joined our team came to us and said, "Jesus, guys, what the hell? You've got it in production already. Nothing ever got done this fast in Skype," which, of course, no offense to anyone from Skype, but it goes back to the point that we should optimize towards the lead time for someone to be able to say thank you for the values that we are delivering. And as we got more comfortable writing Lambda functions and running Lambda functions in production, we went back to tackle some of the more complicated and more core parts of the system. So in the app, we had a timeline feature just like the feature you see in the Twitter, except our implementation was very complicated. It was bug-ridden and unreliable, so much so the QA team declared the whole feature untestable. And at this point, a new CTO had come in and fired everyone involved with the old feature, and I have just come into the team, and so there's no one there for me to figure out, okay, why do you guys approach this way? It doesn't make any sense whatsoever. So instead, rather than the reverse engineering a broken system, we sat down with the product team to work out what the feature should do, and then we went about building it from the scratch by building on top of those events, those rich set of events that we are collecting. So in this case, whenever I create a new post in the platform, that goes into Kinesis, and then a Lambda function runs, and it works out, okay, you've got 3,000 followers, great. And for those followers, I'm going to batch them into batches of, say, 500, And for each batch, I'm going to send a message to SNS, which triggers another Lambda function to then actually add your post to each of your followers' feeds. And the reason why we go to SNS here is so that we can leverage the retry mechanism you get out of the box between Lambda and SNS. This is so that we can avoid doing the expensive part of processing here, which is to figure out who your followers are. As you can imagine, same with Twitter, most of your Twitter users have maybe a handful of followers, but you've got people that are really outliers there that's got millions and millions of followers. So that's something that we need to design towards when we build these kind of systems. And once we have those those users' timelines stored as sorted set in Redis, we can then again expose it as an API using API Gateway and Lambda. And again, using the same strategy we've always applied, we make sure that we proxy the legacy endpoints to hit the new APIs so that, again, we can deliver values to our users earlier without having to wait for the client teams to catch up. And finally, we have a suggestion feature, just like you find in Twitter or Facebook, where you occasionally get told, hey, maybe you're interested in following an ant because maybe you both look at serverless post. Except our implementation was very simple. It's the most naive thing you can think of. And we just returned the first 30 people from the database by account creation time. So it works great if you're an employee for Yabo, because you show up with that list all the time. For everybody else, it's pretty much a useless feature. So one night, I was having a bit of a problem with sleeping, so I decided to do some work and actually created a cron job. In this case, it's a CloudWatch event schedule that runs, say, every hour, kick off Lambda function. And remember all those events that we're streaming to Google BigQuery? And Google BigQuery is excellent for running complex query against basically exabyte-sized data set and get results very quickly. So I can actually run an expensive query that says, give me everyone who's trending the platform based on how many people follow him in the last 24 hours, applying a time decay function to when each person has followed you, and then store those trending users in the database and put an API in front of that. At the same time, whenever you follow and unfollow someone, those events are streamed to Kinesis, handled by Lambda function, and used to update a social graph stored in GrapheneDB, which is a hosted version of Neo4j, a graph database. So I can put an API in front of that to really easily and efficiently give you second or third degree recommendations based on people that you follow or people that follow you already. And again, proxy the legacy endpoint to talk to these two new APIs, combine the results, and pretty much almost overnight turn a useless feature into something that you might actually want to use. And that's just some of the examples of work that we're able to do very, very quickly with Lambda. And there's a lot more where that comes from. But for the rest of the talk, I want to talk about the things that you should look out for or you should consider before you go to production with Lambda. The first thing is definitely find and choose a deployment framework, and don't try to write your own. It's just not worth the effort. The one we use is Serverless framework. I think we've heard quite a bit about it already today. But then there's also Amazon's own SAM framework or Serverless application model. And then there's Apex, Up, Cloudia, Zappa, Sparta. They're just, I think, symptomatic of any new hyped-up technology. There's pretty much a new framework every single week. I think the important thing to remember here is, by all means, try a few, see which one works best for you and your team, but then just mandate that on the team. What you want to do here is to maximize the amount of institutional knowledge sharing so that as people learn about a framework, they can teach each other. Or you also want to minimize the amount of friction you cause for people to move between projects. So if I move from one project to another, how I deploy my code, how I run it, how I test it should be exactly the same. I should spend my time learning about new code base in a new domain rather than figuring out, okay, this new project uses Cloudia. How do I do deployment with Cloudia versus the Serverless framework? As you start writing Lambda functions, you need to figure out how you're going to test them as well. As for testing, this is the best book I've read on testing, written by two guys from London. And it's probably the first book I've seen that mentioned the test pyramid as we know it now, where you can write your tests in unit tests that test your code in the object level. And it works the same as before when everything was running in services. If you've got some business logic, just write a test around that. Then there's also integration tests where you test your code against code you can't change. And since Lambda functions are ultimately just a bit of code that Lambda, the service, is calling on your behalf, so there's nothing that stops you from just running the same code locally by passing it a mock or stopped context, an event object. The key thing to remember here is that the purpose of this test is to test your code's integration with code that you can't change. So even as you run your code locally, you should avoid using mocks and instead just try to hit the same downstream system that your function depends on. And then once your code has been deployed, you also can run acceptance tests where you test whether or not a system works end-to-end as a whole. And as you go up and down this triangle, unit tests give you a much faster feedback loop, but with acceptance tests, you gain much greater confidence in that the work that you've developed, the things you're writing is actually going to work the way you expect them to when it's been deployed. One of the things I learned from the book, one of the key messages I took away is that, and I guess I'll read it, that we find the tests that mock external libraries often need to be complex to get the code into the right state for the functionality that we want to exercise. And the message is telling us that the design is not right, but instead of fixing the problem, we have to carry the extra complexity in both the code and the test. And the second risk is that we have to be sure the behavior that we stub or mock matches what the external library will actually do. And even when we get it right once, we have to make sure the behavior remains valid as we upgrade the libraries. And I think the same principles apply when we are talking about this increasingly service-oriented world that we live in, where we depend on so much of external services that we don't control. And I think it's a futile effort to try to mock every single one of those dependencies that you have. And Paul Johnston, who was just up here on the stage earlier, actually wrote a post a while back to explain pretty much the exact same point. And I think fundamentally, we need to remember that the risk profiles for running Lambda functions are drastically different to those services running on EC2 or containers. And if you focus all your effort on testing what goes on inside the function, and you're mocking or stubbing all your downstream external dependencies, you're missing out a lot of things that can go wrong when your code is deployed. I mean, personally, for me, the first thing that goes bad when my code is deployed and I try to run it is that I forgot to give it permissions to talk to the right DynamoDB table, or the DynamoDB table I depend on has not been created. There's a lot of things that happens outside of my code that if I just test, you're doing unit testing on my code and mocking everything out, I won't be able to catch them. And this becomes much, much worse when you have a complex architecture with so many functions, because remember, those configurations, those dependencies, you have to make sure they're right for every single one of those functions that you have running in production. And it's also my observation that with Lambda functions, your code becomes drastically simpler, and the risk of you actually shipping something broken has now shifted to what happens outside of your code and how your code interacts with those external dependencies. And since the entire purpose of us writing any code at all is so that we can ship working software at the end of the whole process, and that's the goal that we should really optimize towards. I know the fact that we love the fast feedback loop and testing things externally, having to deploy them and testing them is going to slow us down. But for me, the higher confidence I get that what I'm doing is actually going to work is totally worth that sacrifice. And Paul also talked about how if a service that you're using make it really difficult for you to test with, then just go find a competitor. There's so many available choices nowadays. It's not going to be a hard ask. And Nat and Price also talked about how whenever possible, an acceptance test should exercise the system end-to-end without calling into its internal code. An end-to-end test should interact with the system only from the outside through its interfaces. So if you go back to the search API example I talked about earlier, to do the end-to-end testing for this system, we will interact with the legacy system just like our mobile clients would do to create new users, to register them. And then we verify that the search system is working as a whole, that the whole process is working by checking with the search API that this new user can be searched by first name, last name, and username, and so on. Another thing that we notice is that when we are running our integration test, we are executing the code locally and talking to the same downstream dependencies. And when we deploy the code and run end-to-end tests, we are talking to the same code, but via event sources such as API gateway. So the only difference between these two types of tests is how my code is invoked. so that when we are writing our test cases, we can put a one-step definition there, and we can have a toggle in the definition so that by specifying some environment variable, we can use the same test cases for both our integration tests before we deploy the code. So we are confident that when it's deployed, it should work. And then we deploy the code, and then we test the whole thing end to end. And with CI/CD, I think there's a tendency to want to leave that to the end of the process. But since it's really a mechanism to save you from human error and also save you time as well, I think there's a strong argument for you to start thinking about CI/CD much earlier in the cycle. And the book also talks about how we prefer to have the end-to-end test exercise both the system and the process by which it is built and deployed. This sounds like a lot of effort, because it is, but it has to be done anyway, repeatedly during the software's life cycle. And this brings me to all my path annoyances, where you have all these build step definitions that only exist on the Jenkins job definition, and it's not defined anywhere, it's not source control, so eventually at some point someone's going to make a mistake, and you're going to have a broken build, and you have no idea who did it, when, why, and more importantly, what was there before, so they can quickly roll back. And which is why in all of our projects, we have a very simple build script that just provides a simple layer on top of what NPM and the serverless framework gives you already, so that we can use it to drive testing, do deployment, and then drive the end-to-end testing after that. And if you look at the build script, it's very simple, because I'm very incompetent when it comes to writing bash script. The interesting bit here is that by default, we install the serverless framework as a dev dependency in the project. And the reason for doing that is so that when someone else comes into the project, they don't need to have a compatible version of the serverless framework installed on the machine. And in general, this just gets us out of jail with a lot of kind of version conflicts you find whenever the serverless framework itself introduces breaking changes. So I think Anna talked about going from 0.5.x to 1.0. Everything changed when that version change happened. But if you're using a simple approach like this, it means that the project that was created with that same version of the serverless framework will continue to work regardless what version you have installed on your machine. We were using Jenkins, but nowadays I think a lot of people use different tools, and I really like code pipeline and code build as well. And even when you're using whatever CI framework you want to use, I think you should still capture those build steps as a very simple script. In the same way that hexagonal architecture tells us that our application's core domain should be captured and encapsulated irrespective of how it interfaces with the outside world. In the same way that our build steps should be explicitly captured and encapsulated regardless what specific tool we want to use. So we have to expose it via build spec.yaml or whatever it is. It should still be captured as a simple script, so that even for a simple purpose of being able to triggering them locally, and so that you can easily debug those build errors you find. As for continuous delivery versus continuous deployment, we were very much doing continuous delivery, where every time you push we're using Git flow as well. So every time something gets merged, it goes through the pull request, review, and then gets merged into master, it triggers off a deployment process to run integration and unit testing, deploy to an AWS environment, run end-to-end testing, and then promote it to the next environment, and so on, all the way until just before it hits production, which is a manual process for someone to go to Jenkins and click a button. And for good reasons that we don't deploy on Friday, because we also have Friday night drinks as well. As for logging, whenever your function writes to send it out, it gets captured by the Lambda service and shipped to CloudWatch logs asynchronously in one of the few places where you do get background processing from the platform. And you also get UTC timestamp and unique request ID as part of the message. But the problem with CloudWatch logs is that it doesn't make search easy. And most people actually would just take their logs and ship them off to somewhere else by going to CloudWatch logs console and say, okay, take this log group and stream it to Amazon's Elasticsearch or to a Lambda function, from where you can actually ship them to whatever log aggregation service you want to use. The thing to remember is that every time you create a new Lambda function, you also create a new log group as well. And you don't want to have a manual process for someone to have to remember to every time to go back to the console, stream it to the Lambda function. So what you can do is enable CloudTrail so that you can then create event pattern against the create log group API call, so that whenever the system creates a new log group for you, you can trigger Lambda function to subscribe that new log group to your log shipping function. You can also do it with the serverless framework by having this in the serverless.yaml. And also by default, whenever a new log group is created, it's by default to never expire. And since you're paying for storage for CloudWatch logs, so there is a long-term cost implication as well. Again, use the same technique, trigger another Lambda function to just update the retention policy to something like 7 days. And it's all well and good having all of your logs in one place, but as the system becomes more complicated and functions need to work together to deliver a feature, similarly to how when you create a new post, you have to go through Kinesis to another Lambda function to SNS, whilst you also talk to another API to find out who your followers are. And whenever someone comes to you and say, hey, my wife didn't get my post last night, what's up with that? And trying to debug what's going on is really, really difficult because you have to go through the logs for every single one of those things and correlate the timestamp of things. And this is where correlation ID comes in the microservices world. So the way we approach this problem and collecting and forwarding correlation IDs is that we basically wrote our own clients by wrapping around, say, our favorite HTTP client as well as the AWS SDK client for Kinesis and SNS, so that we can capture incoming request correlation IDs, and then we forward them on when we make an outward request. With HTTP endpoint, this would just be very simple HTTP headers, but for Kinesis, it's a bit harder. You have to include it as part of your payload. For SNS, you do get the message attributes that you can tag those correlation IDs on. Another aspect of distributed tracing is about capturing performance information. And X-Ray can do that for you to a degree, where you can see a very good granular breakdown to where all of the milliseconds are going, especially if you're taking the time to instrument your code. And you also get a service map view to see for the same traces. But the problem I found with X-Ray is that it doesn't span over API gateway. So if you call another function via API gateway, then you don't see the breakdown for what happens inside that second function. And it also doesn't trace over asynchronous invocations such as SNS and Kinesis and so on. In terms of monitoring, we also lose the ability to install monitoring agents on a server because, well, we don't have access to the server anymore. And instead, we have to rely on pretty much what we get from CloudWatch. And you do get the basic telemetries about your function. And other providers have also announced support for Lambda, but by and large, most of them just show you the same data from CloudWatch logs, but with a prettier dashboard. Apart from the guys from IOPipe, they do something slightly different in that they give you SDK to wrap your own code so that they can capture additional data points like number of code starts, memory usage, CPU usage, and so on. But the problem with the approach for a lot of these vendors is that now you have to send those telemetry data as part of your function's invocation because, again, we don't have ability to do background processing anymore. And when you're talking about APIs with API Gateway doesn't respond to the caller until your function has finished. So until you finish sending those telemetry data, and all the while your customer is still waiting for your API to respond. Sure, it may be a simple 10 to 20 millisecond extra for every API call, but when you've got microservices, those extra 10, 20 milliseconds can compound when you have user requests that requires a few APIs to complete. So it doesn't take much for you to add another 100 milliseconds to the user-facing latency. And Amazon found out that a few years back, every 100 milliseconds of latency you add is going to reduce your sales by 1%. So those extra milliseconds you're spending to send custom metrics, it can actually come back to hurt your revenue. So can you send those custom metrics in the background instead? Well, you can't, except there's this workaround where you can send them as you can write them as specially formatted messages in your CloudWatch logs because that does get collected in the background. And then in your log shipping function, you can then filter those out and send them as metrics to CloudWatch instead. And once you got all your metrics together, you can set up dashboards, set up alarms, track those application level metrics as well. And just the last thing, I also mentioned the config management as well. When you have many, many functions, I think one of the important criteria for a good config management approach is that you should be able to easily and quickly propagate any kind of config changes across to all of your functions. Nowadays, when you create a Lambda function, you can set up the environment variables and have KMS encrypt them as well. And that's the approach that we went with. We found that, however, with this approach, it didn't scale as we have more and more functions because it's really hard for you to share configuration across multiple functions unless they're all inside the same serverless project, for example. And it also made it very difficult for us to create separation between people who can deploy the code versus people who can access those secrets, because those secrets are then baked in to your environment variables at deployment time. And the approach we decided to go with was to have a centralized config service. And it was here that we looked at services like console and SCD. They're very popular in the, I guess, microservices world, but I didn't really like either approach. For starters, it means now I have to manage an EC2 service again and have to run multiple instances for high availability. And there's quite a steep learning curve in both setting up the services themselves, but also maintaining, managing, and configuring them with the CLI tools. And since we're not going to use most of the features we get anyways, and we just wrote our own API with API Gateway and Lambda, but this is before Amazon announced the SSM parameter store, I think 2016. So nowadays, you should just use SSM parameter store, which does everything for you. You have to remember that any sensitive data you have, like credentials or API keys, need to be encrypted at rest and in flight, and you should have a role-based access to those data so you can control who have access to what. Unfortunately, with SSM parameter store, you can do all of that, where you've got an admin person who will store them in SSM parameter store in an encrypted form, and you'll be encrypted by KMS, and so that it's encrypted at rest, and when your functions boot up, you can ask for those parameters, and your functions is given very precise permissions on what particular parameters it's able to access. And since you're going to be doing this an awful lot, so it's also worth the time to create a robust client library that supports caching. And so when your function boots up at cold start, you fetch them and cache them, and then you can refresh that cache value on the interval, or maybe based on some signal. So for example, if you're using it as a lightweight service discovery thing, where the service URL for different endpoints that you depend on is recorded as parameters in SSM parameter store. So if you start to see 404s or 503s from those endpoint requests, maybe there's a signal that you can use to say, okay, maybe the config values have changed. I should then try and fetch a new one to see if it fixes the problem. And that's all I can fit into just over 30 minutes. Thank you very much. If you want to learn a bit more about some of the things that I've talked about, I'm also running a course with Manning as well, and I've got a couple of free copies to give away today. Just come find me afterwards. And thank you very much for your time.